Number 9 is definitely one of those questions I would skip if given the option. But let's go through it. It's not impossible to solve, it just takes a good while to do it. The graphs are shown on the coordinate plane, so we don't have to graph the two lines. We've already got those on there. This is, you might want to point that out to students, that this has a positive slope, so therefore it would have to be this line. And then this one has a negative slope, the -3, so it's going to be this line. So we already know the two equations and we know the two graphs. They want us to find the solution to the system of inequalities. And we have 4 regions and then an intersection. And I'm actually going to start with that intersection. So we know that point P right here is from origin, it's over 2 and down 1. So I'm just going to go ahead and say that point P is over 2 and down 1. And let me just make sure on that, over 2 and down 1 to point P. So I'm going to use point P in these two inequalities to just see what happens. So I'm going to take a picture so I don't have to keep writing. I'm getting lazy in my old age. Let's see, copy. Okay, so let's bring this down here. I'm just going to paste the system down there. And then point P was 2, -1. So I need that system of inequalities. And then P is over 2 and down 1. So I'm going to substitute this value for P into those two inequalities. So I have y, which is -1, is less than or equal to 2 times 2 minus 5. So I have -1 is less than or equal to 4 minus 5. So -1 is less than or equal to -1. And that does prove to be true, which I would expect that because it's on the intersection. Okay, so then the other one I have -1 is less than or equal to -3 times 2 plus 5. So I'm just substituting the value of P into both of these inequalities. So I have -1 less than or equal to -6 plus 5, and -1 less than or equal to -1. That proves to be true. Again, I would expect that to be true because it's the intersection. Now, I know that the intersection is not going to be, I'm looking for a region that would make these true. This is only one point, but there are a lot of solutions because we're dealing with an inequality. If it were an equation, I would be more interested in the exact equal. But while these are true, there are other things that would also be true, is what I'm trying to say. I did this one just to give you the idea of substituting, because that's the key to this problem. Okay, so let's go back. Let's just put this one aside for a minute and look back here at region 1. So region 1 is right over here. If I were teaching students, I would actually have them to highlight region 1. Make sure they truly understand where region 1 is. It's over here in this region. And have them to pick a point that is in region 1. Now, anytime I can use origin, I usually will, but in this case, I'm going to go ahead and pick the point that's right here. It is in the region 1. That is point 1, 1. Pick something easy and test this system again. So I'm going to put down the system again. and I'm going to check region 1. I'm using 0.11 as my test location for that region. So let's plug it in here and see what happens. So y is 1 less than or equal to 2 times 1 minus 5. So I'm plugging in that point. 1 is less than or equal to 2 minus 5. 1 is less than or equal to negative 3. No, that's not true. That's a false statement. So I can stop right there. I don't even have to check that second inequality. I can tell you on the basis of this one right here that this is not going to fit. So let's pick a point in region 2. And again, I would make sure that students know which region they're looking at, because that could be a big problem. So region 2 is up here, and I'm just going to pick a point that's easy to work with, maybe right in here. So it is over 2, up 1. Over 2, up 1. So let's test that particular point and see what we get. So I'm bringing this in. I tell you what, let me color code because I'm getting confused. This is where it doesn't pay to be dyslexic. So this was the blue area in region 1. Region 2 is orange. So I'll bring it down here. And my point is 2, 1 on this one. So I'm going to say y is 1 less than or equal to 2 times 2 minus 5. So 1 is less than or equal to 4 minus 5. 1 is less than or equal to negative 1. And that's not true. 1 is greater than negative 1. So that's going to be a false statement as well. You don't even have to test the second one. Okay, so now I'm back to region 3. And I want to get a color. Let's do green. Region 3 is right over here. So you can pick a point in any region. And you might be thinking, well, I've already used point P. But remember, point P is on the intersection. The point we choose cannot touch the actual lines of the equation. Has to be separate from that equation line. So I'm going to use this point right here, which is over 1, 2, 3, 4, and down 1. So over 4 and down 1. I'm using that for this pink region, region 3. And I can tell you from experience that 9 times out of 10, it will be the last region you test. So if a student had to guess on this one, I would have them to guess D. Can't be P because P is actually on the equation line. So you could eliminate that one automatically. It's on both of the lines because it's the intersection. And then if I had to guess from there, I would guess D. But let's see. Okay, so this one I'm using 0.4 negative 1. So I will say that y is negative 1 less than equal to 2 times 4 minus 5. So negative 1 is less than 3. That's true. So then I need to test that second inequality and see if it also is true. If it is, this is the answer. But let's test it to see. So we're going to say negative 1, that's our y. Negative 3 times positive 4 plus 5. So negative 1, negative 12 plus 5. So this is saying that -1 is less than or equal to -7, and that is a false statement. And therefore, this cannot be the solution. And look at this. That's why these videos are private. Okay, let me make room for myself to do that. We'll just pretend that that's not there. And I'll have room to do my other. So it has to be D, or otherwise I've done something wrong, which is entirely possible. But I think in this case I haven't. But let's test it and see what we're doing. Oops. That's supposed to be green. And I'll tell you what, rather than do that, because then I am going to have a huge mess on my hands, let's change this one to be pink. And then I'll use green for the last region. When I was teaching this, I didn't teach it often, I'll tell you, because it's pretty tough to understand. I had much better luck when I had the students to color code so that they could see exactly which region they're working in. I remember trying to do this some, and it wasn't easy. Okay, so this needs to be green. And I need to pick a point in region 4. I like this one just because I can draw it easily. And that's going to be over 2 and down 3. So 2, -3. You can use any point in the region as long as it doesn't touch the equation lines. So 2, -3. -3 less than or equal to 2 times 2 minus 5. So -3 is less than or equal to 4 minus 5. -3 is less than or equal to -1. Now, a lot of students are going to tell you that that's false because they're thinking of the absolute value. But -3 is further to the left than -1. So this is a true statement. And then let me test the other one. Remember, they both have to hold true. Whoops. So I'm going to plug in -3 less than or equal to -3 times 2 plus 5. So -3 is less than or equal to -6 plus 5. -3 is less than or equal to -1. That is a true statement. So this is the one that is true on both accounts and does not touch the line. So D should be the one you want. Not my favorite problem. It's basically solved by substitution, but you really have to know that you need to substitute, and that is not easy to do.